So, hello everybody. Welcome to another Inside XRF webinar. My name is Susan Aschenbrenner. Today, I would like to show you some things about the ASTM norm C114-18, which is the standard test method for chemical analysis of hydraulic cement. Maybe some of you are working with it. I hope we will get some clearness into this. We will have a look at the norm itself, and we will have a look at the performance criteria the norm gives and how to meet these performance criteria. If during the webinar you are having any questions, please feel free to put them in the Q&A section of the Zoom. And if there's enough time in the end of the webinar, we can answer some questions on the fly. And if there's not enough time left, then we can answer the questions per mail. So write many questions. We will answer them later. Let's first have a look where we are. So you're watching a FLUXANA webinar, so obviously it will have something to do with X-ray fluorescence analysis. And in this case, we can have a look, what do we even want? We have a sample, and in this case, we are having a very specific sample. We are having cement. We can do some kind of sample preparation with it. Then we can analyze it with our XRF spectrometer, and then we will get some results. And this is always the main aim. We want to get an analysis of the sample. And in the second row, we want to have a best possible result. We want to have a look at precision there. And we have a look on accuracy there. But also one big point is efficiency. We want to have the efficiency getting from the sample to the evaluation of results. And this means time and cost efficiency. To get there, the first question I have to ask myself is, what is my analytical question here? So in this case, we already said we have the sample, which is defined, it's a cement. And we want to know the composition of the sample. Why? Maybe we want to do quality assurance, or we are a commercial analysis laboratory that works according to the to the norm we are looking at today, something like this. And then we have to ask ourselves which analytes shall be measured, in which concentration ranges do we analyze, and which deviations are tolerated. And if we are very lucky, we don't have to decide on these things ourselves, but we get a norm that defines all of these answers to these questions. And in this case, we are lucky. We are having this ASTM norm. And in this ASTM norm, all these questions are answered. Obviously, if you would not have a norm, according to which you could work, you would have to decide on these for yourself. And maybe you would have a little bit less stress because the tolerances would be larger. But in the end, the really important thing is that you get a good result for example, your quality assurance. So in this case, lucky us, there's a norm that defines all these questions. So first question was, which analytes shall be measured? So in the very first table of the ASTM norm, there is this table 1, maximum permissible variations in results. And in this table, in the first column, we are having all of the analytes this norm is talking about. And obviously, there's a lot of analytes, and some cannot be measured with XRF. These ones that are marked with the red arrow, they can be done using XRF quite easily. Sometimes you also need the LOI for your XRF measurement. This is the case when you ignite your sample before measuring it and you want to calculate back to your original material, then you would also need to analyze the LOI, but this would then not be done with XRF. And it's also possible to do sulfide sulfur and chloride with XRF, but this will not be in the webinar today because this is a large topic that can easily be a topic for itself. So now we can see today we are mostly dealing with the norm itself, with the analysis of these analytes that are marked in red. And we will have to keep in mind that we might have to analyze the LOI, and we could also analyze sulfide sulfur and chloride using XRF, but not today. So if we have a closer look on the same table, then we can see that the norm there gives us two different types of tolerances. There's once in column 2, there's the maximum difference between duplicates. And in column 3, there's the maximum difference of the average of duplicates from CRM certificate values. And this is a very large sentence. So let's break these two things down. What's happening here? Column 2 is kind of easy. You are analyzing two samples, so you're preparing a material twice, and then you measure both of your preparations, and the difference between those two different preparations is not allowed to be larger than 0.16 in this case for silicon dioxide. And the other thing that we are looking at is we are still having two preparations of a CRM material, and those two preparations give an average value of whatever, for example, again in silicon dioxide, and this average of the two preparations is not allowed to differ more than 0.2 from the certified value that is given in the certificate. So this is actually, this is just the rules that is given by the ASTM norm. And they, as you see, they are given for all of the oxides that we are looking at today. There are some analytes where you do not have this this column 3, this maximum difference of average of duplicates from the CRM certified value, but not in the case that we are handling today. So, but why should we use XRF in the first place to do all these analyses? XRF is a fast method, and we are measuring many elements with one method. So we don't have to use several methods. We can really cover a vast majority of the analytes that are asked for in the ASTM norm with just one method. Coming back, we said, okay, we know which analytes, we know which deviations are allowed. This is all defined in the norm in the very first table. What now? Next step is we have to decide on sample preparation. In this case, the ASTM norm does not have a very strict definition, not on the measurement and not on the sample preparation that is allowed. It just says you have to fulfill the tolerances. They are giving some examples of methods that can be used, but they are not very strict there. But what you have to keep in mind is that these limits I showed you before, they are kind of narrow for some of the elements in this ASTM norm. And that means that you need a very high quality calibration. and a high quality sample preparation to meet these, for some elements, narrow limits of the norm. High quality calibration, we are going to talk about this later, but in terms of sample preparation, it means the sample preparation has to be reliable, it has to be reproducible, and in our example that is following now, because this is the preparation we chose for all the tests we did for this webinar, is fusion with XRF measurement. So fusion as sample preparation. But this is not a must. You just have to meet the limits that are given in the ASTM norm, and you have to have a reliable and reproducible sample preparation. It does not necessarily have to be fusion. So how did we do our sample preparation? Our sample preparation was done using 1 gram of sample and 8 grams of lithium borate, which is a fusion flux. Both of these 2 compartments were homogenized. Then we had a mixture for the fusion, which was then 9 grams. Then we put everything into the crucible, we fused everything, and then we get fusion beads with 40 millimeter diameter. And this is the whole sample preparation here. So what did we say? Sample preparation, it's very important that you have a reproducible sample preparation because of the tolerances. For fusion process, this is obviously also essential. A fusion process can also be good or bad. So that this fusion process that you're using or sample prep has to be reproducible. And in terms of fusion, this, for example, can mean that you have a controlled fusion program, controlled times, controlled temperatures. The temperature, for example, if you're using this kind of machine where you are having a furnace, the temperatures have to be controlled in a certain manner, so that in the end, you are able to meet these tolerances that we talked about. And also one thing a lot of people are not thinking about is you also have to weigh reproducible. Your balance has to be checked. The people who are doing the weighing process have to be able to do it in a way that it is of some quality and reproducible. So there's a lot of things you have to think about when it comes to sample preparation. In general, you can say that you try to do the least effort that you have to. And but you still try to cancel all systematic errors that you can. Okay, so now we are done with the sample preparation. We know how to prepare our samples. Now we could say, okay, now we are ready for calibration. But there's still some kind of a question mark, and the norm is not like really defining how to do the calibration for this kind of for this kind of measurement. But what is defined in the norm is a great deal about reference materials you are allowed to use for these calibrations. So let's have a look onto this. In point 5 in this ASTM norm, there's qualification for different analysis, and there you can have a whole point just treating certified reference materials. And here, the norm is kind of strict with what you are allowed to use as a reference material. It says a certified reference material must be used in the qualification of test methods and analysts. Acceptable reference cements are NIST CRMs or other reference cements traceable to NIST CRMs. Okay, that narrows down our choosable list of CRMs quite a bit. So then it goes on, the reference cement must have an assigned value for the analyte. Okay, obviously, I need a value to calibrate. And then it says traceability consists of documentary evidence that the assigned values of the reference cements are compatible with the certified values of NIST CRMs. What does that mean? The CRMs that you are using, they have to be compatible to NIST CRMs. They are basically normalizing everything to NIST CRMs. NIST is just the standard for this norm. So in the end, you have to decide, I need an acceptable reference material. They can be NIST CRMs. They can be CRMs that are traceable to NIST. There are also a lot of CRMs in the market that are traceable to NIST. Or I myself have to have a documentary evidence that the CRM I am using is compatible with the NIST CRMs, so that this CRM will give comparable results when I'm using it. So ASTM does only allow standards that are NIST or NIST traceable. So what did we do? We are having a bunch of FLUXANA CRMs. Now we could say, okay, we cannot use it. But what we did is we created a testing scheme, and we wanted to know if other CRMs, in this case, mostly FLUXANA CRMs, are fit for purpose. This is also transferable to other CRMs, but in this case, we are looking at FLUXANA CRMs. So how did we do it? First of all, we established a cement method that was only based on NIST standards. I put a list of some of the NIST standards we used there. And what we did then is we took our test CRMs and we measured the test CRMs in this method, and we checked for the tolerances that are the norm requirements. So the table that you saw in the very beginning, where you had all these different tolerances, these were the tolerances we checked for with our test CRMs, measuring them in a NIST, completely based on NIST calibration method. So again, all these calibration curves, they are completely based on NIST standards, and the other CRMs are measured as unknown samples now. So I transferred the table from the norm into something that makes it a little bit easier to compare. So we see we are having the same two things that we saw in the table before. We have the allowed difference between mean of the duplicates and the certified value, which is kind of the trueness of our measurement. And then we have the allowed difference between duplicates. So this is precision. So we are checking, is our value true in terms of does it fit to the certificate? And we are checking, is it precise enough? And if we are having a look at this one, this is the CRM 101. We are having certified values up here. We are having measurements, the mean of the measurement, and then we are having the difference between the mean of the duplicates. So the difference between the certificate and the mean of the duplicates. So this is the trueness factor here. And then we are having the difference between the duplicates themselves. So this is basically this minus this, and this is the difference between the certified value and the mean of the two measurements. And as you can see, this fits quite good into the calibration we did just based on NIST. And it definitely fits into these tolerances that are given by the ASTM norm. So then this is what we did with Plenty. So we transferred it from just the CRM 101, we transferred it to a lot of our cement CRMs to have a look which ones can be considered comparable to NIST in terms of this ASTM norm. And as you can see, there's 1, 2, 3, 4, 5 different CRMs here in this picture. There's many more. I just didn't want to be the boring one who's just showing numbers. So in this list, you can find all the CRMs that we checked and that passed the check against the NIST CRMs in the calibration method we set up. So you can see this is quite a lot of CRMs, SEM and CRMs that passed that test. Okay, so let's head back and we can see, okay, our reference materials, we are allowed to use NIST, or we are allowed to use compatible with NIST CRMs. So now we know how to set up the calibration. And then for us, it was also important to see if our calibration, which is based on the FLUXANA CEM set, which is a commercial set that you can just buy and integrate into your process, if this one is also showing the ASTM conformity. So is this calibration that we are having conform, ASTM conform? That was the other question. And this is also the question you have to ask yourself when you're using a calibration, no matter which kind of calibration. If you set it up yourself, if you're having a set from somewhere, this is always the question that is important here. Does my calibration fulfill the things that ASTM wants there? How do I find out? There is a part of the ASTM norm where they are stated how to validate your calibration. And it says when 7 CRM segments are required, as for demonstrating the performance of rapid test methods, at least 6 of the 7 shall be within the prescribed limits, and the 7th shall differ by no more than twice its value. So it's again this magical table that we are looking at. And we now know we have to have 7 CRMs as control samples. We need to measure them, and we have to be within these limits for at least 6 of them. And the 7th one that is maybe a little bit out of the limits, there it cannot be more than twice the limit. If you're using more than 7 CRMs, then you need to have at least 77% within these limits. And the rest also not more than twice the value. And when you use less than 7 CRMs, which is also allowed, but then all the values have to be within these limits. Okay, so this is what we did for our calibration. And I guess these tables will look kind of familiar now. It's basically the same thing that we did to prove that our CRMs we are using, that they are compatible to the NIST CRMs. But in this case, we are using our own calibration, not the one that is done with the NIST, with only the NIST. There's also NIST, but no, only the NIST NIST CRMs in the other calibration. This is a mixed calibration, and I took one NIST standard here just to make sure that that I'm aligned with all of my other measurements, that I'm still compatible with NIST. Okay, so what did we do? We did basically the same thing as before. We measured twice. We did this for 7 CRMs. We can see 4 here. And we checked if precision-wise and trueness-wise, we are within the ASTM levels. So we are having these limits. And again, we are checking if each number will be okay within the limits. And as you can see, green is good. For these 4, all of those are within the limits. But we need 7, so here's 3 more. And here you can see that for 1 CRM, my silicon dioxide value here for my silicon dioxide trueness value is a little bit off. But when I compare it to all the other 6 reference materials I measured, then I see that most of them are within their tolerance limits. And what did the ASTM norm say? The ASTM norm states when 7 CRMs are required, then at least 6 of the 7 shall be within the prescribed limits, and the 7th shall differ by no more than twice that value. So in this case, you can see that my limit would be 0.2, but I'm off by 0.22. So this is far away from being off twice that value. So in this case, I can say, okay, I validated my my calibration using the NIST standard, using other standards that I proved to be compatible to the NIST standards. And now I can say my my calibration will fulfill these tolerances that are given by the ASTM norm. And this is the exact thing that you will have to do with your calibration. You have to check according to the norm if you can meet these tolerance limits that are given in this very first table of the norm. Yeah. So let's sum this all up. We said we are coming from our sample, which is a cement, and we want to know the cement's composition. And we need it, for example, for quality assurance. And now we have to ask ourselves the question, which analytes, which concentrations, which deviations, and we are lucky people because there is a norm that defines all of these different points. And this norm is the ASTM norm we were talking about today, the ASTM C114-18. I showed you some of the essential things which are actually in this one table. And I also showed you that for this part, sample preparation, calibration, these two, the norm gives a lot of freedom, which is not bad because you can decide a lot by yourself. But what do you have to decide? In terms of sample preparation, you need a reproducible sample preparation because for some elements you are having kind of narrow tolerances. And that means you need controlled programs, whether it's for pressing or for fusion. If you do something with temperatures, the temperatures also have to be controlled, and so on and so on. Basically, you have to check that everything that will give a systematic error will be cancelled in a way that it's still efficient. So doing the best we can do, not overdoing it and taking a lot of time and effort there. Also something, I have to say it again, what people are forgetting a lot of times is that reproducible weighing is also very important. So check your balance, check if the people who are weighing know the tolerances they are allowed to weigh in, and so on, and get rid of systematic errors wherever you can, because then you will be able to meet these tolerances. Okay, then we talked about reference materials. Here The norm is kind of strict. We know we need to use NIST or compatible to NIST. I showed you our way to document that CRMs are compatible to NIST. This is just the rules of this ASTM norm. This is because it's standardized. And yeah, this is just very important to keep in mind here, that we are really strictly bound to these kinds of reference materials, which is actually very special. And then for the calibration, you have to check it for the tolerances that are stated. And this is in table 1 of the norm. And if you keep in mind this part, because this is also very essential, the sample preparation, even if it was just a small part of the webinar today. And this part where you have to have like high quality reference materials, because this is what this is about. They want to have high quality reference materials. Then you will also be able, with a little bit of calibration skill, to meet these tolerances that are stated in the ASTM norm. Okay, and then we will also be able to have our composition defined and to do our quality assurance. So thank you for your attention. Next month in September, there will be another webinar about ferroalloys, analyzing ferroalloys using XRF. It's an application webinar. It will be very interesting if you are interested in this kind of application. With a short look to the, yeah, there's not enough time to answer a lot of questions now, but I will answer your questions via mail. So just have a little bit patience with me. I will answer your questions in a bit. And yeah, thank you again for your attention, and I wish you a very, very nice day.